Hey guys, welcome. I don't usually make tutorials on brand new experimental features in Unity, but the brand new Graph Toolkit was just released and it's too cool for me to pass up. And since the upcoming new animation system and Shader Graph 2 are going to be based on this graph framework, I'm confident that support is going to continue for it for a long time. So in this video, we are going to use the new Graph Toolkit to create a branching dialogue system. So again, I want to reiterate, this is an experimental package as of the time of this recording, so there will very likely be API changes and improvements and upgrades across the board, so some of this will change, I'm sure. That being said, I have been playing around with this tool quite a bit, and it's really nice. So who is this for? This tool is mainly for tool programmers. So you have full freedom with this tool. You have to create your own nodes and handle the runtime execution backend. It will not handle the execution logic for you. This is a front-end framework focused on the authoring experience. So it handles the UI of the graph and it handles it really well. You handle everything else. Now, the Graph Toolkit team has put a lot of love into this tool. Unity released a 29-minute video showcasing all of its features. I will link that down below in the description. So I'm not going to go through everything here, but what I will do is rapid fire show you all of the coolest features it handles as quickly as I can. Starting now. You can replace wires with portals, sticky notes, placemats. There's a level of detail system to ensure nodes and elements are readable from a distance. There's various snapping and alignment options. Rectangle select, freeform select, freeform delete, minimap, subgraph support. You can dynamically change the number of inputs or outputs on a node. And of course, automatic undo and redo support. So here is my scene right now. I already have a canvas with a dialog container on it. We have our visual elements, speaker name text, dialog text, and then an empty container for buttons, which is where we'll spawn buttons to select our various dialog choice from our branch. So first things first, we need to install the package. And this package requires Unity 6.2, which is in beta right now. Once you've installed that, we want to install Graph Toolkit by name. And you can type in com.unity.graphtoolkit. And they do already have 2 samples included, which is really nice. So in my dialog graph folder, I'm going to add an editor folder, which is very important. And in there, we're going to create a script called dialog graph. This is going to handle the creation of our actual graph asset. And it's going to be a very simple script. We add the unity.graphtoolkit.editor namespace, as well as the Unity editor. And first we want to inherit from graph and just make sure that it's the right one because there are quite a few. We want the one that is from the Graph Toolkit namespace. And now we're going to create a static method called createAssetFile. And this line is how we create our graph asset, passing in dialog graph as the type. And above this method, we add a menu item attribute, and we're going to do it in assets create dialog graph and pass in false. This is not a validate function. And finally, add a constant string called asset extension. And you can make this whatever you want. I'm just going to say dialog graph. This is how the actual file extension is going to be chosen. So with this, our file name will actually be .dialog graph. And finally, we need to make this serializable, and we need to add the graph asset extension attribute. Okay, let's go ahead and create our graph. So we go to create dialog graph. And like I said, you can see right here, we have our graph.dialog graph. Now we can double click on that to open it up. Not that we can do a whole lot with it yet because we haven't created any nodes yet. So let's do that next. So still inside our editor folder, we're going to create a dialog nodes script. This is also going to be super easy. Right now, we're going to create 3 nodes, a start node, which will actually trigger the start of our conversation, an end node, and a regular dialog node with no branching options. We'll add the branching options in a little bit. Just note that they all have the serializable attribute and they all inherit from node. So we have 2 override options, but the one we want is on define ports. And since this is the start node, there's no input we're going to need. So all we need to do is define an output port so that we can connect it to something. And we do it like this and adding .build to it. All right, so already if we go to our graph and we right click and create node, or you can just hit space, we now have some nodes in there, but start node is the only one with any ports at all so far. Notice it's just called start node, which was the name of the class, and it says out here because we entered that as a string. All right, so that's all we need to do for that node. So moving on to the end node. This one's also really straightforward. It's just like start, except it only has an input and no output. All right, the dialog is just a little bit more involved because we actually want it to be able to take in some data. But first, just like the other two nodes, we want an input and we want an output port on this one as well, because we need to connect them to something. So again, that's just for the connections. Now we're going to add two more input ports of type string. One is going to be for our speaker, and one is going to be the actual dialog line. Okay, with that done, let's go back and check out our graph, and we're going to set up something really simple to test this out. We will start the dialog. We're going to connect that to a dialog node, and then one more, and then end the dialog. You can type the speaker and dialog lines directly into the node, but if you click on the actual node itself, it's going to give you details in the graph inspector over here, which makes it a little easier to read. As of right now, if you want to expand this text area to give you more room to type, you would have to make your own custom data type, then make your own custom property drawer. But I was chatting with the Graph Toolkit team, and they are hoping to add support for a text area attribute soon, which will be much easier. So fingers crossed. Now, we could have dozens and dozens of nodes here, so if you don't want to have to repeat certain things, like the speaker name, for instance, let's create a string property up in our Blackboard here, one for each of our speakers. And then you can just drag those in instead of having to type them out every time. Okay, so let's go ahead and save our graph. Now, the thing is, we can't reference these node classes from a monobehavior in our game because they are editor-only scripts. So we got to do something about that. So outside of the editor folder, let's create a runtime dialog graph script. This is going to hold all of the information that we typed into our graph. We want to make sure it inherits from scriptable object. So here we'll create one more class called runtime dialog node with all the data we might want. So node ID, speaker name, dialog text, and text node ID. Then in our main class up here, we'll create an entry node ID, as well as a list of all of our runtime dialog nodes called all nodes. So this is just going to hold a bunch of data, but we somehow need to populate all of this with the data from our graph. And that is where our dialog graph importer script comes in. So let's create that. And again, it needs to be inside our editor folder and open it up. We are going to want a few different namespaces here, so I'm just going to add all of them right now. And this script is going to inherit from scripted importer. And we add the attribute scripted importer, pass in a version number there, one is fine, as well as our asset extension so it knows what to look for. And now we override the onImportAsset method. So this method runs whenever an asset is imported, like when we create the graph or when we save the graph. So a couple things first. Here, because this is in the editor folder, we can actually load our editor graph. But we're going to populate our runtime dialog graph, so we need that, and we're creating a new instance because it is a scriptable object, not a monobehavior. And this is the recommended way to do it for scriptable objects. And we also want a node ID map. We want that so that we can look up node IDs from their inode interface. So first, we're just going to do one thing. We're going to loop through every single node in our graph and give it its own unique ID. I haven't yet found a way to access a unique ID on the nodes through their API, so I'm just going to create one myself. Now every single node has a unique ID, which we're going to need a little bit later. Next, we find our start node to see what it's connected to. That first connection is the starting point for our whole conversation, so we save its ID in our entry node ID variable. Next, we're going to loop through all of the nodes again, and if it's a start or end node, we can skip that node. And then for each dialog node that we find, we're going to do a couple of things. So first, I'm going to set up a helper method. And one more actually, and this one is going to help us get our port values. We're making it generic because it could be returning any kind of value. Now, in this case, it's always going to be a string because we're only looking for the speaker name or the dialog text, but just to make this expandable, I wanted to set it up this way. Now, if no ports exist, then we're just going to return the default. So if it's a string, it's going to be null. If it's an int, it'll be 0, etc., etc. We check if the port is connected to a variable from our Blackboard, and if it is, we're going to grab that value. If it's not connected to a variable, then we're just going to grab whatever we typed into the node manually, which we'll call our fallback value. So in the process dialog node, we get the speaker and dialog text from its input ports. And here's the most important part. We're going to look at its output port, see which node it's connected to, and then we're going to save the ID of that next node. This is how we're going to create the chain and tell our game how to get from one line of dialogue to the next. Now to call this method, first we are going to create a new runtime node and grab its ID from the dictionary that we made earlier. Then if that node is a dialog node, then we're going to process the dialog node. And finally, these last two lines are just a little bit of Unity magic. They attach our new runtime data to the graph asset itself. This is what's going to let us just drag our single dialog graph file into an inspector field later on. Okay, we're very close. Finally, we're going to create our last script, and it's not in the editor because this is going to be our dialog manager, which will attach to our actual dialog game object here. So we're going to need a reference to our runtime graph, our dialog panel so we can enable and disable the dialog box, and we obviously want to change our text as well. And we also want to store a dictionary where we can look up a runtime dialog node from a string. And finally, we want to store what our current node is. So first, we're going to populate our dictionary by cycling through all of our nodes. And just to make things easy for this tutorial, we're just going to start the dialog straight away in the start function. So we can check if we have an entry node to our dialog like this. If we don't have a node ID assigned, then our string will be null. If we do have a start node, then we'll call show node. Otherwise, we'll just end the dialog. Now we're going to do a very similar thing in update. We check for a mouse click and make sure that we have a current node. And we can call the same thing here, except we pass in the next node ID instead of the entry node ID here and here. So in our show node method, just to be safe, if our dictionary doesn't contain the node ID that we pass in, then we're just going to end the dialog. If we make it past that, we can set our current node, activate our dialog box, and finally display our dialog text and speaker text. And now to end the dialog, we're just going to turn off the dialog panel and null out our current node. So we already constructed a simple graph, so let's just populate these in the inspector and give it a try. And that's not working. Okay, so after some debugging, I realized I missed a very crucial line in our graph importer script. In our loop here, we need to add the current runtime node to our list of runtime nodes. Now I'm going to hit save on my graph one more time, and that's going to trigger our importer script to run. And now it is detecting 4 nodes here correctly. So let's try that again. Okay, awesome. Now that was a lot for a simple linear dialogue system. There are easier ways to do it. However, since we already set all of this up, it's actually going to be very easy to add branching choices. So first we need to create our choice node. So back in our dialog nodes script, we're going to create that class and we'll override our onDefined ports like normal. We need an input. And on top of giving us branching choices, this is also a dialog node, so we still need a speaker and a dialog input port. Now, I love this, by the way. I want this node to be dynamic, meaning we are going to make it so that we can choose how many output ports and input ports it's going to have simply by entering an integer. So we need to give that a name, and let's do that up here. And now we get our option by the name we just set up. And we can call try get value, and we'll output an int called port count. And now we do a simple for loop and add an input port, which is going to be the text that we display on our choice button, as well as an output port. Okay, next, to actually add the int to our node to make it expand, we need to override onDefine options this time. And I'll add a node option of type int and pass in the option ID. Now, as it is, this will work fine, but it is a little bit annoying because every time we enter a new key, it updates automatically, and I'd rather it wait for us for when we press enter. So to do that, actually, first let's add a default value here because that's a little bit nicer. And now we add a new attribute, and we want the delayed attribute, which will wait until we press the enter key. All right, so we should be able to go into our graph, and now let's set up a little test scenario. I'm going to connect this to a choice node, plug in a speaker and some dialogue, as well as the button text. And for each output, I'm going to connect it up to a dialogue node so that we know that it worked. And we'll end each one. By the way, you don't have to enter an end node. We coded this in a way so that it'll end if it finds blanks as well. I just happen to find that this looks cleaner. Now, when we save our graph right now, it's not going to be able to do anything with this new data because we need to populate some data from our graph first, which means we need to add a few things to our runtime dialog graph. We just want our choice text and the destination node ID so that we know where it's going based on our choice. We'll also add a list of choice data in our runtime dialog node. And now you guessed it, to populate this data, we again need to update our dialog graph importer script. So just like process dialog node here, we need a process choice node method. So again, we're going to need a speaker name and dialog text. And this is a little bit crude, but it does work just fine. So we're going to find all of our output ports where the name starts with choice. Then we're going to loop through all of those. We can grab the index and then get the port based on its full name. And then we're going to create a new choice data and populate it. And then add that new choice data to the runtime node's choices. All right, so finally up here, we can just add an else if. If this is a choice node, then process the choice node. And just to be safe, I'm going to save this again to make sure that it catches all of those updates we just did. And finally, back in our dialog manager, we need a button prefab, which we'll create in just a minute, as well as a transform so it knows where to spawn them in. And in update, we also want to add if our choices is equal to 0, because if we do have choices, then we want to actually click on the button itself. Now in our show node, first, if there are any buttons in the container, destroy them. And now if we have choices, we loop through all of them, spawn in a button, and set the button's text. And then we need to set up the button's onClick event, which is, do we have a destination ID? If so, show the node. If we don't, end our dialog. And just in case, in end dialog, let's also destroy any lingering buttons. All right, so I'm just going to set up a button prefab really quick. I've set up my button container like this. You can hold down Alt and Shift and click this option here. Then we can adjust our height and make sure this is set to middle center. Now we can spawn in lots of choices and they'll be nicely spaced out. Now let's delete those out and finally populate these and try it out. And there you go, that's working nicely. And to create a new graph for a new conversation, again, we just create a new dialog graph and populate it in there. So now we have this nice, easy branching dialog system that's super easy to create using Graph Toolkit. I hope you guys enjoyed. Thank you so much for watching, and I will see you next week. Bye.